Welcome to qnawire.
Okay, so in this case, you have a mass that looks something like this, where you have, um, so this thing, you're told, is a uniform piece of metal that has, so this is some y distance, and that is some x distance. And essentially, so they tell you that this sheet is just uniform, and they want you to locate the center of mass given the coordinates of, so you know that this is 10, that's 20, and that's 30. Same thing here, 10, 20, 30. And they want you to find the center of mass of this whole thing. Um, so you know that the center of mass, to find the center of mass, you want to calculate the product of the masses. So essentially, it's the sum of products of the masses, and then you divide by the total of the masses. So this will give you the location of the center of mass in this direction. So in this case, I can, since this is in two dimensions here, I can use x and y separately for r here. So in this case, because you are told that this is a sheet of metal, but this is a uniform sheet of metal, so you can actually just transform this problem into a problem where you have uniform masses located at the center of these squares, right? So if you assume that you have uniform mass there, uniform mass there, uniform mass there, another one here, another one here, and another one here. Because this whole sheet is uniform, so if you take each block separately, it just looks like you have a mass that's right at the center of each of these blocks here. So this system here is going to be slightly easier to analyze than this. So notice now you can start writing XY coordinates for each and every one of these masses. And because we know that to get to here, it's 5x plus 5y. Here it's 15x plus 5y. Here it's 25x plus 5y. So we know that, so this total thing weighs mass m. So this summation here is equal to m. But we split it into 6 equal squares here. So that means that the top here is going to be, so each mass is going to be m over 6. So let's say start with this one mass here, for example. So to find this expression for this mass is going to be m over 6 times the distance in the x direction for that m over 6. So I'm starting with the x here. So this is, again, up here, so that's 5x. So that's going to be times 5. And then I go to this mass here, which is 15 away from 0. So that's 15x. So I'm going to add, because the summation, again, m over 6 times 15. Then I go to this mass, now 25. So I'm now going to add again the same mass, because this is uniform, times 25. So that's these three on the row. So now you go up. Notice again, now this the x is just changing, but the mass doesn't change. So this is going to be the mass times the x coordinate here, which is 5, again, plus this one, the mass times its coordinate, which is now up here it's 25. No, it's 5 again, because we're going in the x direction only. So the last mass, notice, is going to be, so this is 10, so that's 15 over here. The x is now 15. So that's going to be the mass times 15. So these are in centimeters. So if you calculate this whole sum here, you can actually just factor out the mass, because the mass is going to be the same for each one of these 6. So this is going to be the mass times the sum of these coordinates, which should get you something around 70 or so, over, now we add up all the masses, but if we add up all the masses, that's just m over here. So notice that these can cancel, so that means your x coordinate is just going to be 70 over 6. And 70 over 6 is something around 11.7 centimeters in this case, in the x direction. So we could just go 11.76 I. And then you just go ahead and do the same thing in the y direction. You know that all of these have mass m over 6, so I can go ahead and factor out that m over 6. And now I just add up all the y coordinates for each one of these masses, and divide the sum of the coordinates. So I find that sum, and then I divide that by m again, because this formula is still the same in both directions. So these will cancel. So what I will have is just the sum of the y coordinates of each of these pieces divided by 6, which should give you something around 13.3 in the y. So I can just call this 13.3 j centimeters. So your final coordinate for the center of mass is just 11.7 I plus 13.3 j centimeters.